So I need to back up a bit. So we're giving a patient 450 mils of stuff.
Yes.
In 5 hours.
Yes.
Now, how did the 45-minute part? Oh, how many drops?
It wants me to calculate the amount of dextrose water that the patient should receive every 45 minutes.
Okay. And then was this 60?
It just said it was a drop factor of 60.
So I think that's saying then 60 drops per milliliter.
That's what I would say.
Yeah. Let's see. And just want to clarify, the other part of the question was, well, we're not trying to find out how much dextrose, as in like grams of dextrose. We're just trying to find out how much of the stuff we're giving them in 45.
So, calculate the amount of dextrose water in milliliters.
Given in 45 minutes.
Yeah, it wants to know how many milliliters are given in 45 minutes.
Okay. So one thing to think about is our answer is going to come out in milliliters, right?
Right.
So keeping that in mind. So if we were to do, let's see. So for 400, we have 450 mils per 5 hours, right?
Right.
So everyone's happy with that part? Okay, but we don't like that. So first thing I'm going to do is convert the hours into minutes, right? So 1 hour, and we have 60 minutes. But we don't want the minutes. But what we do want to do is take into consideration, we're talking about 45 minutes, right? So I should be able to stick my 45 minutes right there over 1. Okay. So now you can see that our units are working out, right?
Right.
So that should be how many milliliters in 45 minutes.
Okay.
Okay. And so this part doesn't really matter. Yeah.
I think that I was just like overcomplicating it in my mind.
Well, it's a funny question. We didn't do an example like this.
Yeah, no, that's okay.
No. So you have it there right now? Yeah. So you can, will it be able to enter it in?
I did that a whole different way. Like I didn't do it much.
Well, now there are, yes, there are a lot of other ways you could do it. And in general, I really want you to try to work on the dimensional analysis.
There wasn't any example, so I was like, oh.
No, this was kind of a weird one, and this one really kind of forces, I think it's a good one to force you into trying to use dimensional analysis. But you can kind of think about it. Here's your rate, and So what did you guys come up with? So a few of you I saw pushing buttons.
So it comes up to, the answer is 7.5, which is around to 68.
So does this come up to 7.5?
67.5.
Okay. So you get 67.5 milliliters. And they wanted how many decimal places, too?
They just said to round to the nearest milliliter, so I'm assuming they
Oh.
wanted to round
To 68, yeah.
So I'll check and see if that's the right answer.
Okay.
Yeah.
Yeah. Gotta love that little green X.
Overcomplicating it in my mind.
Well, it's a tricky one, actually.
But thank you. I appreciate that.
Absolutely. Yeah.
If I couldn't figure out dimensional analysis on the test and I did it my own way, would that stop me anymore?
It will a little bit.
Okay.
Yes. The biggest thing I want you to get from this week and a half of stuff is the dimensional analysis. Okay? So, yes, please try as much as you can, even with the easy problems and building up to the harder ones. Because like today, again, so we did some kind of messy ones on Wednesday. A little bit messy maybe, and we've got some kind of like that, where it does really help to be getting the dimensional analysis to help you through the problem. So.
Number 1 on the worksheet, real quick.
Oh, which, by the way, let me know if you want to talk more about the worksheet. I mean, the answers are online, but I can pop them up here and we can look at those as well.
I think the answers through the apothecary were online, but did you find the answers for the rest? Yeah, those are.
Well, they are now, I think. But,
okay.
Well, it just depends on. I put part of them up there and I kind of waited, and then last night I put all of them up there, even through 9, which is what we're doing today. So I assume if you check, where did you check?
On the little notification thing, but maybe I didn't look in the right spot.
I wonder if it didn't do a notification because if I updated it as opposed to adding it, maybe? I don't know. Now, when did I send you the email?
Yeah, you sent an email, but I don't think I saw
Because I think...
the notification online.
Yeah.
I just looked in my email, and then I saw everything, and then I went in and looked.
Okay. So let me send me... Maybe I uploaded the wrong one, too, but I think I did the right one. So you actually should be able to check all the way through. But you want to do number 1 on... in chapter 8?
Yeah, lower sheet.
Okay.
Is how many grams of dextrose and salt are contained in 600 milliliters of D 4 1/4 and X?
Okay, and the question that we're really trying to find is grams of dextrose, right? And grams of salt. Okay.
But since it's not water, I wasn't sure how to go from milliliters to grams.
Okay. So it comes back to this. What this means right here is 4% dextrose. Okay? And so you can think of the 4% in two ways. You could say one way is this is 4 grams out of 100 milliliters. Okay? So that's how you would interpret that part of it. And then one of the things I think I showed on the first day was how many different ways they write this. Sometimes they'll do it as 4% dextrose, and then they may actually tell you the percentage here. A quarter of normal means 0.225% saline.
I did 4 1/4% of dextrose.
Right. Yeah, and again, I mean, it's the best we can tell is that the manufacturers aren't very standard with this. But so when you see the dextrose, look for a number on either side of it. Sometimes they may tell you more directly. Sometimes it's more obscured. Okay, so and now the way we interpret this part of the problem is, again, this is a normal means 0.9%. Okay, that's what normal saline means. But then we're saying, but it's a quarter of that strength. So you imagine chop it in half would be 0.45. Chop it in half again would be 0.225. And that's percentage. Okay. So then over here I could say this is I could go 0.225 over 100. That's okay. That's how you'd write a percentage. Or more importantly probably is that it actually means this many grams out of milliliters. Okay. Okay with that? Now then the next step is the easy part. We're saying we've got a whole bag of this stuff, right? 600 mils. And so now I can just grab this thing, put it right here. Actually, let me put this one here. This will be 4 grams over 100 milliliters, and then that's going to pop up the number of grams of dextrose, right? This would be the dextrose here. And then normal saline would be the same thing. Take your 600 over 1 times, but we use this one here, 0.225 grams over 100 milliliters. Some of you may recognize that, in fact, one of the things you can actually do here, it's a shortcut, but you're actually going 600 times 0.04, which is kind of how you would treat a percentage, right? So, does that answer your question?
Yeah, I made it way harder than it should have needed to be.
And again, this here is it's pretty cryptic. Yeah. Okay. Any more? Ready to move on to the new stuff? Thanks for your questions. And I'm glad you're writing them down, bring them in, and so we can talk about them. So we're going to do 9 and 7 today. Okay, and that finishes it up. Which then really could be the test, and it could be on Monday. I don't know though if we have time for review, but so let's do this. Let's go through 9 and 7 stuff, and then let's talk about it. Okay. So give me one moment here to get the slides up. good news is once we get to this far through it, really we're just doing the same stuff, just little different questions, different materials. So actually it's not that crazy different. But we'll see how this next little bit goes. If I can get it to come up. There we go. Okay, maybe this one here, let's just talk about it. Maybe you don't need to for us to do this one. How many teaspoons? See, 1,200 milligrams. Oh yeah, 1,200 milligrams of Zithromax. It's one of the few I at least can say. I'm not very good with my drugs. The label says 200 milligrams per 5 milliliters. So would you be able to do those conversions easy enough, or would you like to do this? We can do it. Okay. So the big question is, we want to know is how many teaspoons, right? So we have 1,200 milligrams. So what we start with on the label right away, it tells you essentially the concentration. Okay. And which way will I write it? Good. 5 milliliters over the 200 milligrams. And so that's going to be nice. Now we have milliliters, but that's not the question. So now if you were to look at your sheet, this is kind of where, probably in Pearson I gave it pretty direct for you, but if you only had that one conversion sheet, how can we get to... Milliliters. That's right. We can go right to ounces. Yep, 30 milliliters per 1 ounce. 1 ounce is 2 tablespoons. Awesome. Good. And 3 teaspoons. There we go. So that'll come out as teaspoons. Do you want to finish it, or do you feel like we're good to go now that you see that? Good to go? We can save the steps here. So the one thing I want to point out, of course, this conversion factor, that's just unique to whatever drug it was, what it told us on the label, right? So, of course, that's not going to be in any table anywhere beyond the label. These guys, of course, will be in your table, right? So then the thing is, this is one of those I want you to memorize, and you can see that on your sheet that way, right? And this one comes back to the simple idea. If you give somebody a glass of water, 8-ounce glass of water is how many milliliters? $240 milliliters, right? Okay. So that's one of the reasons I like you to have that memorized. Because if you are tracking, ins and outs and all that stuff, you might end up doing that conversion a lot.
So on the test, are you going to have all of the other conversions except for the highlighted ones? Correct. Okay.
Yeah. So the ones that are highlighted, unfortunately, in gray, but good, you made yours in yellow. Yeah. Yes. Yes, those are the ones that are in yellow are the ones I just think everybody needs to know those. Okay. And the rest of the table will be right there on the last page of your test. Yeah, actually, your test is even printed. It's all ready to... Okay, let's go do some more of these little guys. Again, now this one maybe not... If we've talked about converting pounds to kilograms and back and forth, right? You can do that in your head sometimes. Or you could even use, what's the conversion factor?
1
Yeah, you said 2.2, 2.2? Yeah. If I add this one little thing in by saying it's 12 pounds, 5 ounces, how would you start that? Do you know? Oh, you're close. You're close. 12 pounds plus the 5 ounces, but we've got to do one little thing to the 5 ounces. And make it into pounds by dividing it by, 16. There's 16 ounces in 1 pound, right? So if I that's a percentage, essentially, 5 out of 16. So that's going to give me, what is that? 0.3 maybe or something?
Yeah, 0.3.
Okay, so this is going to give me 12.3 pounds. So I think we're okay with that little step now that you see it. And then, of course, you would do the times 2.2. Whoops, there we go. Or if we were doing dimensional analysis, you'd do it that way. But it's going to give you the same results, okay? And let me know if skipping this last step bothers you, okay? We can do it. But I'd just like to be able to spend a little more time on a couple of these that are a little trickier. So let me explain what's going on here. So, in fact, let's start in the second sentence. We have 200 milligrams. This is what the doctor's ordered. 200 milligrams QID. See, QID, that's on the prohibited list, right? But what does it mean? Yeah. 4 times a day? Yeah. BID is twice. TID is 3. Quad. Okay. So this means then really the person is getting 800 milligrams of whatever this stuff is every day, right? 800 milligrams per day. That's what's being prescribed. The question for you, though, is if you look on the back of the bottle, it tells you that typically they give somewhere between 40 and 60 milligrams per kilogram per day. Okay? So typically it's, that would be the wrong number. 40 to 60 milligrams per kilogram of body weight per day. Okay? That's what the bottle says. So the question is what being given here, does that make sense? Okay? Every once in a while people make mistakes, and so this is a way to be able to check. So does everyone understand what we're trying to do? So I want this over here is coming out in milligrams per day, right? So I want my answer over here to be also milligrams per day. Yeah. Okay. So let's do that. It says 3 to 6 doses per day, right? And they're doing 4. So good. First little step there. That's right. Kind of right in the middle of the window. So what we're hoping is when we do all the math is that the 800 falls between, when we have to finish converting these, should fall in the middle of those, right? Okay, so we want to get rid of kilograms. How can we do that with the information we have? Yep. There's the person's body weight. We have 22.5 kilograms, so that goes away. And this stuff comes in. Oh, that's it. Okay, guess so. The next ones will be a little more complicated. What's that come up to be? What is it? 900 milligrams. And then this would be 1,300 milligrams per day. most of the time the way you'll do this is do it one time with the first number, do it again with the second number, so you'd actually like do the problem twice, okay?
Oh, so you're multiplying the 22.5 times 40, and then it can consistently?
Yeah.
Okay.
So this one here is a little easier because we actually didn't have to do any extra conversions in this. But most of the time, I would recommend you do it one time with the 40, do all the math, come back and do it again with the 60, do all your math, okay? So you'll have a minimum and a maximum. So this is, of course, their min. This was the max. And what you want to do is say, does this fall between those? And in this case, the answer is no, it doesn't, right? It's too low. Okay? So in this case, the answer would be no, we don't think so. It'd really be worth, I mean, it's probably not going to kill the person being a little low, but it'd be worth saying, wait, did you really mean that? Okay?
Well, I guess, does it depend on the, for infant child? Because sometimes for medicine, you have to give less for a child, right?
Right. So, I mean, there are a whole set of equations to calculate pediatric doses. You know, we could bring some of those up too, actually, at some point. Pearson didn't have any of those, but maybe we should bring some of those up. Show you some of those equations. Are we good with this little problem so far? I think I've got another one that adds a layer of complexity to it. Or I hope I do. I meant to. Let's see. Yeah. I'm going to go redo my examples. I messed up somewhere, but it'll be close enough. So I have 20 milligrams per kilogram per day. And see, the person weighs 55 pounds and it comes in 200 milligrams per 1.5 milliliters. So the question is, how much are you going to give them per day? And in fact, we could also talk about the dose. So in this case, we didn't start with what the doctor said. We're just looking at the label, and it's not. We don't have the range up here. So what would we do to figure out how much?
Pounds into kilograms.
Sure. Okay. So I could go. Some of you would like to do that over separate, and that's okay. I'll stick it in here because we just need the practice. 1 kilogram is 2.2 pounds. And now we can grab our 55 pounds and put that right there. So we've got rid of the kilograms. We've got rid of the pounds.
And then you do the 200.
Yes, because this actually is going to come out, and what we're giving is some in liquid form, right? So let's do that conversion. To get rid of the milligrams, I will write 200 milligrams here and 1.5 milliliters up here. So now that goes away. Now this answer is going to come out in milliliters per day, right? Okay, and that's good. What if, let's see, 4 equal doses. So let's add another piece onto here. If I want the answer to come out per dose instead of per day, and we have 4 doses per day, what would be this last little piece here?
1 day on top is 600 feet.
1 day, and I think you mean 4, right?
4, yeah.
Yep. Yeah, that's right. 1 day, 4 doses per day. So now you can see that the day part even cancel out if we're really trying to stick with this dimensional analysis stuff. So our answer comes out in milliliters per dose. Can you guys tell me what this comes up to be? Or maybe you can give me the numerator and denominators here.
It's 1,650
7,650. Okay. Thank you. 40 you said, right? Okay. Is it just under 4 or just over 4?
3.75.
Okay. Milliliters per dose. I assume it's that. Back to the cherry cough syrup.
Oh, sorry. I didn't put that. Yeah,
So
the number is different.
The denominator should actually be 1760.
Okay.
Think about that too.
No, that's why I have all you guys do it. We'll just kind of 1760. And I'm not asking you to double check your number before you give it to me. Just toss me out a number, and there's plenty of us to double check stuff. What is that? I don't know. I'll take your word for it. What do the rest of you guys say? Let's see. 100. Okay. So if we take math by consensus, then we're going to get what, like 0.8 out of this or something? 0.9. 0.9. Give me one more decimal, please. 4. Okay. 0.94 milliliters per dose. Okay. All right. So let's go into the other little group I have here. I think I need to go back and change one of my examples there, though. Do you guys recognize the word parenteral? So that means somebody's going to get stuck with a needle when you hear parenteral. Enteral, that means someone's going to swallow something normally. Okay? It's going to go through your digestive tract. All right? And is everyone okay with the fact that a 14 gauge needle is bigger than a 27? Did you know that? Okay. And see what some other trivia. Oh, did you know that they pretty much never use the 5 and all these bigger ones? That's only like if you're hooking up to an IV or something. So if somebody comes at you with a 15 or 20 mil syringe, they normally aren't going to stick you with that. So if it's going to make you. And have you guys heard of the word tuberculin?
Tuberculosis test that they do.
Actually, this is the name they give to a 1 cc syringe.
Oh.
Yeah, I know it sounds like the word like tuberculosis or something. Yeah, but yeah, if a 1 cc syringe, we could say that, but we could also say a tuberculin syringe, and it means the same thing. Some reason the 1 cc or the 1 milliliter got its own special name. Nobody else has that one. Yeah. The one little thing I wanted to point out when you look at these pictures, and in fact, yeah. You can see the two syringes the same size, right? This one starts out 0.1, 0.2, 0.3, up to 1. There's your 1 cc or 1 milliliter, right? This one starts out 10, 20, 30, up to 100. Okay? This one, what do you use that one for? I know. Most of the time it has a special, unique use. So normally it's for insulin. So even though they are the same syringe and you could make the same measurements, this one is almost always going to be used for insulin only. So, piece of trivia for you. Okay. There you go. There's your standard set of syringes. Notice you normally don't have, actually they might have had 6s a long time ago, but basically these are your numbers. It's going to be 1, 3, actually there would be a half out there too. But you're not going to find a 15, and you're not going to have a 9, right? These are the kind of the standard sizes you have. Okay. And again, You should never use these with a needle on the end. Okay. Here's one more piece of trivia for you. You'll notice in a couple of your problems they talk about having units. Okay? And again, this has to do more with insulin. Instead of saying milliliters, we talk about units. And this is pretty funny. The unit of a unit is the amount of insulin required to take the glucose, the blood glucose of a healthy 4.5 pound rabbit that has fasted for 24 hours. I'm sure that was voluntary. Makes the blood level drop down to 2.5 moles per liter within 5 hours. You will not be tested on that. But when I'm looking at the unit thing, it's like we don't use this in math, physics and engineering. And so I had to look it up. And when I found the definition, it was just too funny to believe, right? So some poor rabbit was forced to fast for 24 hours, and they gave him a shot of 1 unit of insulin. And anyhow, I got a kick out of that. There, now you know. So here, let's do a problem with that. So here we have 2 million units. You know what IM stands for? I think we already talked about that. Maybe?
That was the injection one.
Yeah. Do you know what the M stands for? So we have 2 million. So nobody knows what the M is for in the IM? It's the muscle. This is one of those deeper shots. They're going clear down in the muscle, not just like sub-Q, subcutaneous would be just like under the skin a little bit. This one here, all the way in there, down in deep. Okay? This is stuff my wife likes and I know really very little about. But okay, so the problem says QID. It's funny, we're back to the prohibited units. Need to go change this. Let me pick that out. Times 7 times day. Dose available, 1 million units per vial. Okay, so the question is, how many? So we're going to do then, we have, so what's implied in the problem is that there's 1 cc, or I'll write it both ways. 1 cc or milliliter contains 1 million units. So this part up here is implied. Or maybe I should say just everybody knows it or something like that. That's the way they do business. So 1 million units. So then the question is how much you're going to give. And you can see, of course, the million units cancels out, And now we're just down to 2 milliliters. 4 times a day, right? So this person is going to get 8 milliliters, and then, or 56 milliliters total. So just wanted to point out how this little unit thing works, okay? So when you see the units, they're saying you have 1 million units in 1 cc or 1 milliliter. Is that fine? And then one other thing that will pop up in your Pearson stuff, they're going to ask you, I messed up with the slide here again. I think I failed to copy them over. Maybe that's what's bugging me on some of the slides. They're all updated nicely on my hard drive and not on the H drive. So it'll talk about give 200 milligrams of a drug, and it's labeled 15%. So this is very similar to how when we talked about the 4% dextrose and the half or quarter normal saline. So the percentage means 15 grams over 100 milliliters. Okay? So then what we're going to do is start off with the 200 milligrams that we're supposed to give. And what we're giving is as a 15% concentration. So the first thing is that's in grams per milliliter, right? So I need to convert this into grams. So if I have milligrams here, grams here. Remember this?
1,000 milligrams.
Yeah. There we go. And now I can do the 15% part, which says for 15% we'd have 15 grams in 100 milliliters. So you can see now we've got our milliliters. Is that 20? No, it's not. Okay. Okay. So it kind of runs you through the problems you're going to run into Pearson. And I think you should be able to finish now that other worksheet. So any questions on that? So, think you'd be ready for the test on Monday? Could be ready for that? As if you're going to say yes. I mean, my goal, so I really would like to spend kind of like a day, almost a day and a half starting the new stuff next week. So for example, another option would be on Monday, we can answer any questions you have with this and start a little bit of the statistics chapter and then do the test on Wednesday. That's a possibility. So for better or worse, now it is new material, but then the material won't be anywhere close. It'll feel totally different than this, so you wouldn't be confusing it. So what do you think?